Okay. It says the function given by f is this formula. Cool. That doesn't tell me a whole lot, I just keep going. Other than I might label this so I don't forget. Here's f. The figure above shows a portion of the graph. Got it? Which of the following could be the values of the constants a and b? Okay, whenever I read a question where they ask me to find the value of constants, I try to ignore the constants and think of something else that I see. Okay, just got to ignore the constants. So what I notice is the picture up here appears to have a vertical asymptote at x equal 2. So f has vertical asymptote at x equal 2. And f has a horizontal asymptote at y equal 3. Both good there? So ignoring a and b, what catches my attention is this one right here, because I need you to memorize the following. I told you, you memorized it earlier in the year, you may have forgotten, so you gotta rememorize it. These two things are the same, right here. The limit, as x approaches infinity, of f of x is exactly the same thing as the horizontal asymptote of f. And this could be negative infinity as well. In this problem it's not, because we're only going to positive infinity, but you need to memorize this. Both good there. Okay. I always say the equal sign is the key to solving nearly every problem. So how can I create an equation that combines this memory with this information? Because I've got to use the equal sign. How do I write an equation that combines what I see here with that memory?
So the limits of x approaches to infinity equals horizontal asymptote, which is 3.
Does that make sense?
Yeah.
That's perfect. So I'm going to write that down. So that's exactly what you should be concluding. You should read the problem. You say, okay, I don't want to think about a and b, but I do see a horizontal asymptote of 3. So remembering this, I can now create an equation, which is the key to the class. So I write the limit as x approaches infinity of f must equal 3. So now I have an equation that gives me a way to proceed. Like I just keep track of the equal sign and usually things will work out.
But then how do you know if the infinity is positive or negative?
Oh, that one from the graph. Because notice here in this problem, we're only talking about x going this way. So x is going to infinity. And we're not doing anything over here. Does that make sense?
Yeah.
Okay. So you get to there?
Mm-hmm.
Okay, so this is like what we talked about earlier, Jesse. You've gotten that far. Hopefully by writing this, it will lead you to write something else. So seeing that equation, can you think of something else you could write which would help you to make progress? Because remember, when we're trying to find a and b, we're trying to do familiar things. We're not trying to invent some new process. Okay.
You compared, well, if the limits, you compared terms that add.
Very good. We're trying to find the limit as x approaches infinity of f. That's somehow supposed to equal 3.
Yeah.
According to our notes, we've got to compare terms that add. So how do we do that here? So the thing you're missing is they told us the formula for f.
Oh.
I'm making it a little hard because I have to keep switching screens. They told us this is f. So remember, the key to the class is the equal sign. So wherever I see f, I can put this. With me? So that means the next thing I can write on the paper is, this is the same as saying the limit as x approaches infinity of, what was it?
Ax squared plus 12 divided by x squared plus b.
So now you see that, can you think of anything to do?
So,
No, look at your golden notes.
do you
You're doing a limit. What do we always do when x approaches infinity?
take the biggest term?
So read the notes, what does it say?
Compare terms that add
What does that mean in this case?
ax squared over x squared.
No, compare terms that are adding. What are the terms that are adding?
Ax squared plus 12.
So ax squared is being added to 12.
Yeah.
So as you compare, you think about ax squared compared to 12. And you're going to let x get bigger and bigger and bigger. Which of those two will become important, which will become unimportant?
X will become
The 8, we've got to compare the terms. So the two terms are, say the two terms again,
ax squared
and
12.
and 12. So when I compare those two terms, which of those two is most important as x grows? Ax squared. So that's what you write on the next line. You say, oh, if this is true, then this is also true. What could you say about the bottom?
X squared.
What does it all have to equal? Squared, sorry. 3. So that's why I keep saying you've got to keep track of the equal sign. With me? What's the next step in the limiting process, Jesse? What's the next thing you would do?
Factor and divide.
Can we do that here?
Yes.
Yeah, it's already factored. So now ask yourself this. As x grows forever, finding a limit means find what this is for this x. So what is this when x grows to infinity? It's just a. But because I didn't lose track of the equal sign, I now suddenly found a. You just have to not lose track of the equal sign. So we start with the equal sign. Just got to make sure we don't lose track of it. Does that make sense?
Yes.
Cool. So we found A. We got to go back and find B. So I use the other clue right here. F has a vertical asymptote at x equal 2. Way back in September we learned, or we didn't really learn, we reviewed from a previous class, that means the following. That means that this function f, so we've got to write equations again. When you plug in an x equal 2, that's going to have to be some number divided by 0.
Wait, isn't that undefined?
That is undefined. That's very good. Because at the location of the vertical asymptote, the value of f is undefined. And it's undefined because you end up having a number divided by 0. So how do you make this formula for f end up being a number divided by 0 when the x value is 2? That's what this is saying. How do you make this formula for f be a number divided by 0 when the x value is 2?
B is -4.
B would have to be -4. Questions?
So with like taking
Oh, yeah, for sure. Yeah, like, here's a quick example. I see this question, my brain says, oh, that's just an antiderivative. That doesn't usually take too long. I'm going to do that.
okay.
Then I go to the next question and say, oh, that's just a regular limit problem. It doesn't usually take very long. So I do that one. Then I go to the next one. That one I might skip first time.
Yeah.
Because as soon as I glance, like, I'm not sure exactly what they want. So I skip it. Next one, I go, that's just a derivative. That's good, so I do that. So that's what I do. And then once I've done all that, I go back. And say, okay, this one looks kind of medium, let's work on that. Because you want to get the easy ones first.
So didn't you say that you don't need to guess? Like don't guess on the practice test, but like guess on the